Okay, so first of all, why do we call it a butterfly waft? Have you ever seen about how butterfly swing its wing? Yeah, this is a very beautiful butterfly. So it's a animation. So similarly, how butterfly works is actually butterfly is a quarter turn waft. So you can see this on close and goes to open. So when open, the waft this is actually perpendicular to the waft body. When the waft is actually aligned with the waft body, so it's on the sealing position, or we so called the full close position. So that's the reason because of the motion of this quarter turn waft, this butterfly waft is very similarly like butterfly wings, the motion of the butterfly swinging its wings. So we call it a butterfly waft. For butterfly waft, actually we can segregate it or we can differentiate it through a few of different end connection. The first type on the leftmost is a wafer type, and on the middle is a lug type, and on the right hand side this is a double flange. This is a animation view lah. So it's actually on the left is showing about the disc is full close, and when the disc is perpendicular means the waft is on full open position. So what does it look like in actual product? So you can see it is this is a wafer type. This is lug type. Lug type you can see there's like a ears, and this is double flange. Okay. If you have any questions, please feel free to leave it in the comment section. Then I will answer to you later. And continue. So this is the butterfly waft exploded view. So we actually explain on all the parts of the butterfly waft. From the top, we have a nut to tighten on the compression plate. So this is a compression ring which is used to compress on the shaft seal. We have a retaining ring, shaft. So I actually have highlighted the main component of the butterfly waft. First of all, of course, we look in the waft body. Like just now I mentioned, on the left here, this is a yeah, you can see the arrow. Okay, so on the left here, this is the wafer body, and on the right here, this is the lug type body, lug type end connection. So we have a spacer, bearing, and so on, of course. Then another important is a shaft seal. Then this is a butterfly disc. Okay, the diagram here showing is actually a double eccentric butterfly waft. I will explain further about what is the eccentric or offset of the butterfly waft later. So this is a waft seat. When the waft disc is aligned with the waft seat, so it's on the full close position, so it's in contact and it's a sealing, so you'll prevent any fluid or medium pass through, so we so called the seat tightness. Okay, on the right side is an example for the lug type butterfly waft. Okay, here comes some diagram about how to operate a butterfly waft. Over here you can see this is a butterfly waft and this is connected to the shaft. But how are we going to quarter turn or rotate the waft in a quarter turn motion, means in a 90-degree? First, we can actually have a manual lever. So it's a lever type. You can actually rotate it clockwise to close, counterclockwise to open. So in a 90 degrees, or we so-called again quarter turn. For those butterfly with a larger size, of course, when the size is larger, so the friction and the torque value required is larger. So it might be very difficult for us to operate it by using the manual lever. So we have that option on by using a manual gearbox. So with a gearbox hand wheel, that we can actually help you to rotate the valve, or we so-called stroke the valve. What about if we don't want to do it in a manual way? What are the other options? Sorry, it's a bit blocking the. Okay, here on the left you can see this is a pneumatic actuator. This is the lug end connection or the lug type butterfly valve. Is connected to this blue color. This blue color component or device is the actuator, the pneumatic actuator. And on the top, this is actually a position monitoring, or we so-called a limit switch. On the right hand side here, we have this is an example of the double flange butterfly valve, and is controlled by a electrical actuator, or we so-called a motorized actuator. Okay, let me take a look on the comment. So many different kind of valve sharing. Yes, Wai Chong, please stay tuned and do share with your friend about our schedule. Then they can actually come on every Monday to learn about this technical session. Of course, it's not limited to Monday, but our technical session will mainly put it on Monday. On Tuesday, Wednesday, and Thursday, we have a different interesting topics to you as well. Hi, Roslina. How to know when to choose wafer type or lug type? Okay, first of all, during the front-end engineering design, there should be some what do you call the selection, or the what do you call the specification, which is stated by the user or the design. And secondly is actually, if you can see the wafer type over here, you can see is actually in a consideration is actually much lighter body weight, or the actual weight of this wafer type comparing to the lug type. So the consideration is usually on the low pressure type we can use on the wafer type. When the pressure and the size goes larger, then we will prefer on the lug type or the double flange type. Hi, Louis Kong Sifu, thank you. I thought to call you and ask about this from Lincoln. Yeah, Lincoln, if you ask in this session, there's a free of charge. If you call me and ask, there will be some consultation fees to be applied. So, Wai Chong, any limitation on size or pressure rating for different type of butterfly valve? Does it mean different type? Is it mean on different end of connection, the different body construction, Wai Chong? Like just now I mentioned, if you are referring to the construction on wafer or lug or the double flange, for the larger valve size and the higher pressure rating, we will opt for the double flange type, which is to ensure on the flange tightness. Okay, let me continue. Heng Chuan, how to differentiate double offset and triple offset butterfly valve? Very good question. This is the content we are going into it. Okay, so other than the end connection, which I've introduced just now for wafer type, lug type, and double flange end connection. So for butterfly valve, there's actually different type of design as well. So from the leftmost, this is actually a concentric design. If you can see, this one, part number 2, this part number 2 is actually the butterfly disc or the valve disc, and the shaft is part number 1. Number 4 is the valve body, and number 3 is the valve seat. Okay, so in all these four types, the leftmost on the concentric type is the valve disc, and the shaft position is actually at the center line of the body. Means this is number 4, at the center line of the body. From this vertically, this at the center line, and as well at the center line of the pipe center line of the pipeline. So pipeline, this is on the horizontal line, is located at the center position. So for this type, we so call it concentric. So the next one is actually we can call it a single offset. Why do we call it single offset? If you can notice now, the part number 1, the valve shaft, the butterfly valve shaft, is actually slightly offset from the body center line. The body center line, this vertical dotted line, now the valve shaft is located in this area, while the pipe center line is no difference, so it's still at the center of the pipeline. So the reason of having this, actually for this, a single offset is not so common. Usually they will be having the concentric type, double offset, and triple offset. Of course, there are some design of single offset, but probably not so common. The improvement from concentric to single offset is actually to reduce on the wear and tear, and also to lower down or reduce the friction. And now we go to the double offset. The double offset butterfly valve, usually we call it as the high performance butterfly valve. Okay, if you can notice it here, this part number 1, this is a valve shaft, is now located, is offset from the body center line, and as well from the pipe center line. So it's located in this location. I will have a more clearer diagram later. And for this triple offset, we cannot see it from here, but you can see from the part number item, the part number 3, the component number 3, the differences is the seat. The shape of the seat is now different. You can see this actually to match on the elliptical shape. Okay, so now the single offset, this is a single offset. The shaft is offset from its body center line, offset from the body center line. For the double offset is offset from the body center line and also from the pipe center line. And the triple offset is add on another, which is a conical offset shape in its seals, which means it's a seat lah. And the disc connection, or the disc spelling is a bit typo. Can use for isolation, Rosalina. Yes, The butterfly valve is suitable to be used for isolation valve or so-called on-off application. Later, I'll go through as well on the advantage and disadvantage of using the butterfly valve. Wai Chong, you're welcome. What is the difference between butterfly valve and check valve? Butterfly valve basically is require the involvement of energy or force, which is like using a manual, or we can use a pneumatic actuator or pneumatic actuator, hydraulic actuator, or electrical actuator. Check valve is actually to prevent on single flow, so it's only allow a single direction flow in the pipeline, and it's actually not required any actuation. Is a self-acting valve design by using the support from the spring. So on the check valve, on the construction and design from JJ Rajan, you can see it further in our upcoming presentation. When we use double offset and we use triple offset? Okay, Heng Chuan, upcoming, I will actually clarify your question. So this is a concentric butterfly valve. Just now when we mentioned on the valve disc, you can see the shaft position is located at the center of the body, the center line of the body, and as well the center line of the pipeline. Usually for this concentric butterfly valve, the seed material we'll be using is EPDM, PFA, NBR rubber, what do you call rubber, nitrile buna N, or FKM. So we so-called the soft seed by using the concentric butterfly valve. You can see in this orange circle area. So this the how do we determine or how do we differentiate the offset of the butterfly valve? Okay, next we go to the eccentric, or we so-called the single offset or single eccentric butterfly valve. So this is a butterfly disc. You can see comparing to the concentric butterfly valve. Now the valve disc, the shaft is located offset from the body center line. Same thing for this design of valve. Usually the seed material we'll be using is EPDM, PFA, NBR, Buna N, or FKM. So for both of these design, usually the application will be more on like a fire water, deluge valve, for seawater application because of the seed material of EPDM, PFA rubber. So it will be suitable for seawater or water application. Same thing. How can we differentiate this? You look into the shaft position on the valve disc. So you can see now this is actually, of course, it's difficult for us to see whether it's offset from the pipe center line. But very obviously, now you can see it's actually offset from the valve center line. Okay, so this is coming back to the question from Heng Chuan. When we use double offset and when we use triple offset. Okay, so the first two when we have discussed is we are using a soft seed, or we so-called the rubber line, EPDM, PFA, NBR, nitrile buna N, or rubber, FKM. Same thing to concentric and a single offset. So now this is a double offset butterfly valve. You can see from this diagram, yeah, this is the butterfly disc. So there's actually the shaft is offset from the valve center line. It's slightly offset from the valve center line, and here as well, this is the pipe center line. Sorry, this is so-called the pipe center line, and now you can see it's offset from the pipe center line. This is how it's located in here. So this is a rotation when the valve move from full open to full close, and the direction of full close. So this is how the disc will actually get in contact with the seed material in this location. For this double offset butterfly valve, the seed material usually we'll be using is Teflon, PTFE, reinforced, RPTFE, reinforced PTFE, modified PTFE, KLF. KLF is usually used for the cryogenic. So for this double offset butterfly valve, or people commonly will call it as high performance butterfly valve, is because how the improvement from this double offset helping on the reducing the friction. So here this is the explanation of the advantages of double offset butterfly valve, or we so-called double eccentric. Is actually further extend the effectiveness of seed tightness, and also on this rotation is actually transmit a camming action to the disc and swing the disc completely away from the seed, preventing jamming, and eliminates wear points around the disc at the top and bottom of the seed. Or in short, actually I will put two conclusions is it eliminates the wear point around the disc at the top position and the bottom position. So when it turns and when it rotates, it's actually reducing on the wear and tear. So you can have a higher, longer durability. Means it's a higher life cycle and also a longer service life lah. And secondly is by eliminating the wear points or the contact point is reduce the friction and as well reducing the torque value. So it's reducing the size of the actuator required or the torque required to stroke the valve. Okay, get back to the question from Heng Chuan. So for the first three type, the concentric, single offset, double offset butterfly valve, we are using the soft seat material. And when do we need to use a triple offset butterfly valve? Okay, so this is one of the example of the triple offset butterfly valve. This is a butterfly disc. You can see on the number one, this is the offset from the center of the valve. So this is actually the center of the valve. Now the shaft is located in this area. So and secondly, from the center of the flow port, or we so-called on the center of the pipe, the actual is in this gray color. Now is slightly offset from the center. So for the first two offset is totally same as the double offset butterfly valve. And now on the triple offset, some people call it triple offset, or some manufacturer we call it trip offset, TRIP, or some call it triple, TRIPPLE. For the triple offset butterfly valve in the market, there are different manufacturers having slightly different design or slightly different features on the valve disc and also on the valve seat. But theoretically, this is the explanation, which is the disc of the valve is actually machined to the elliptical shape. So it's just like a oblique slice from a solid metal cone, or you just try to imagine on an elliptical shape. So when the valve is closed, the elliptical disc of the butterfly valve will be sitting on the major axis, and it will displace the seat ring outwards. If you can see it here, yeah, the seat ring will go outwards, and the top and bottom of the valve seat will comes closer to the valve disc. So when the valve goes to open, this will go on the reverse direction. So this will comes in, and the top and bottom was towards outwards. The reason is when it's towards outwards, so it will reduce on the friction and also reduce on the wear and tear. So the seat material usually we'll be using with the metal seat, like a metal with a hard chrome, for example, Incolli 825 base material with the hard chrome, Mnemonic with hard chrome, and so on. So basically, for high performance metal seated butterfly valve, we will require a configuration or design of triple offset. The advantage is it has a long lasting superior seat tightness. It can, by using this triple offset, it can achieve on tight shut off, or we so-called the ANSI FCI FCI class 6 lah. And this is a machine to the elliptical shape, is creating a lower friction and excellent wear resistance, which basically how the movement of the seat ring will reducing the wear and tear, and also a lower friction when there's a reducing the contact point. So on this design, using the metal part, so there will be no resilient part or the soft part exposed to the medium. Okay, let me take a look. Is it the higher offset the better valve performance as the wear reduced from Jia Chen? Okay, not exactly. So, but for the first three types, for example, on the concentric, single offset, and double offset, when it goes to the higher offset, yes, by using the soft seat, then the performance is better because it's reducing the wear and tear. So the life cycle and the service lifetime will be higher, longer, and also reducing the friction. So the force required for you to operate the valve will be reduced. Is it triple offset or triple offset from JJ Razi? Yeah, some manufacturers require triple offset or triple offset. Yeah, or some people call it trip offset as well. It's depending on the different valve manufacturer, especially the major player. But more or less the design, the consideration is the same. Butterfly valve suitable for gas pipeline. Yes, Avancha. So gas is depending on the gas medium as well, of course, whether it's a corrosive or erosive. But most of it, no problem. We have been using a lot of these butterfly valve for example, on the hydrogen services, hydrogen gas. Butterfly valve have any direct for install in pipeline from Yi Xiang? Butterfly valve have any direct? I didn't really catch the question from Yi Xiang. Maybe you can retype. Hi, Justin from JC. Hi, welcome. Hi, Jaja. Thank you for you're welcome. Yeah. So let me continue. So when do we use a butterfly valve? Of course, when we are applying the butterfly valve, there's an advantage of the butterfly valve. First of all, the butterfly valve is the design is more compact because on the face-to-face is using this design comparing to the ball valve, gate valve, glove valve. So is a lesser weight and require less place. For high pressure rating, yeah, it can be up to 1,500 pound and 2,500 pound as well for the high pressure rating. Tie shut off over long cycle life. So this tie shut off, of course, is subjective to whether on the soft seat or the metal seat. It can be equipped with the live loading packing and achieve fugitive emission class. Fugitive emission class means from the if there's any any emission from the packing area. Ease of automation is for this rotary valve. It can be equipped with the gearbox, what do you call, electric actuator and pneumatic actuator. Lower overall install cost is because on for example the valve width comparing apple to apple, same size of the butterfly valve comparing to the same size of the gate valve and the ball valve, the overall weight is lesser. Then another thing is because on the pipe support, so the weight is lesser, the overall weight of the pipeline is also reduced. So you might not need the a big or well-designed pipe support, or we so-called the what you call the spring hanger. So for butterfly valve, the design standard is accordance to API 609 on the face-to-face, B16.5 for the end connection, for example on the double flange, API 607 for the fire safe, EN 593 for the is similar to the API 609 design, EN 558 for the face-to-face, EN 15848 for the fugitive emission class as well. So we have talked about the advantage. What are the disadvantage of using the butterfly valve? The disadvantage is the disadvantage is for this butterfly valve is actually not suitable to be used on the high differential pressure application. For the high differential application, we so-called the high DP on the P1 minus P2, or we so-called the inlet minus outlet. If we require a very high differential pressure, means pressure reduction, we should be using, for example, on glove valve. Secondly, not suitable for pipeline, not suitable to be used on pipeline required pigging service. So on pigging service, which mean on the last session when we discussed about the ball valve, so we talk about the pigging work. Okay, so pigging or the pig is actually a cylindrical device or the component. So it will actually sweep through the pipeline by scraping the side. So if there's some debris, also they can actually use on inspection gauge to inspect on the pipe thickness. So try to imagine now, what we have is actually the butterfly valve with the disc at the center or is a position within the flow. So the pig will not be able to pass through. So it's not suitable to be used on pigging service. Lower CV value comparing to ball valve. Of course, when you are using ball valve, especially the full ball ball valve is actually the same orifice diameter according to the pipeline size. So there will be a very minor flow friction, and of course then it will actually create a high or giving a higher CV value comparing to the butterfly valve when this is positioned within the flow. So same to number 4. This of the butterfly valve is always positioned within the flow, therefore a pressure drop is always presented in the flow. So butterfly valve, when you are operating it, so the pressure drop is always there and higher comparing to the ball valve and gate valve. Installation direction. Okay, Yi Xiang. Yeah, this is actually very okay. I understand what is coming from Yi Xiang. It's a very good question. I think I have put something here. Okay, yeah, this is it. So the installation direction from Yi Xiang is actually very depends on the design or construction of the butterfly valve, but most of the butterfly valve is actually a bidirectional, means there's no specific installation direction for the butterfly valve. which I will share here is the application of butterfly valve is in conclusion or in summary, in concise, the butterfly is suitable to be used on both on-off and also modulating control application. So it has a superior control characteristic. So you can see on the right bottom, this is the theoretically, of course, by changing on this design and also the orifice design, so it's actually will be having the different curve, but theoretically this is a modified what do you call modified equal percentage flow curve. So wide rangeability because it can give a high CV as well, but of course, it's, like I mentioned, is a lower than the ball valve. Wide option for various application. It can be used on cryogenic. If you want a fire safe design, high temp, niche requirement, vacuum services is suitable to be used as well. Good dynamic stability in both flow direction. So this is actually pertaining to or referring to the comment from Yi Xiang, which is talking about. So most of the butterfly is suitable to be used on both flow direction, but there are some of the method-seated butterfly valve, they do have the unidirectional. Okay, so thank you. Yeah, let me take a look on the comment before I end the session. For my opinion, pipe support are always better to be in place. This can really reduce the stress being applied on the pipe itself, the joints, and also on the valve to allow the valve to last longer. Yeah, I do agree with Lincoln. Of course, for the pipe support, we so-called the spring hanger. Uh, it's not just a simple hanger. So it can be a lot of involve a lot on the stress calculation as well. So yes, it's always recommended for the pipeline itself. Then we should have a calculated pipe support. I don't want to comment. My voice has not been heard. Yeah, because I didn't hear your voice, but I see your comment from Lincoln. Don't be sad. Okay. So okay, just about the right time. So now it's on 2 o'clock. Thank you, everyone. So that's my sharing for today. Is I try to make it short and simple. So because it's introduction to the butterfly valve, and we talk about the applications, it can be suitable to be used on both on-off and modulating control. On-off, which is just now Roslina was asking for the isolation as isolation valve and as well to the control valve. Okay, please do stay tuned to our next upcoming topics on next week, next Monday on 1:30 is the same time. Next week, we will be sharing to you about the fundamental of gate valve and the application. Okay, actually not so simple one, got a lot of calculation and engineering done onto it from Lincoln Chow. Yes, I do agree. Yeah, if there's an opportunity of slot, then we should actually include or the sharing about the pipe support again. In fact, we have shared before lah. Yeah, so no harm. I mean, if someone is interested, please leave in the comment, then we will share to you all again. Okay, that's all for my sharing of today. Wishing you all have a great week. Hope my session today is not making your Monday blue or Monday heavy Monday or busy Monday is become a more headache. Okay, have a great week ahead. I see you all again. I will see you all again. Bye bye. Oh, finally I see a new friend, Boon Kiet. Thank you. You're welcome. See you all again. Bye bye.